Hi, my name is Rahn, and this is my 4th year in the BioScience program. Thank you for coming to listen to our talks today. So, I think we can agree that all of us are different from each other. For example, we have physical differences, including skin color, hair color, and height. We have different personalities. Some of us may be more introverted, while others are more extroverted. We have different preferences. Some of us like Jimmy John's more, while others like Mizuki. All of these are examples of a concept called heterogeneity. This is just a big fancy word that means differences. Our immune system even displays heterogeneity, or differences. There are differences in how our immune systems respond to the same environment. Here, I'm talking about allergies. For example, some of us may be allergic to dust or cats, while others may be allergic to peanuts or gluten. Some of us may have no allergies at all. Another example of heterogeneity or differences in our immune system is how we respond to being exposed to bacteria or viruses. For example, some of us may get really sick for days or become chronically ill, while others only get mildly sick for 12 hours or not sick at all. Again, these are examples of the concept called heterogeneity of the immune response. So just as there are differences in how our immune systems respond to being exposed to bacteria and viruses, there's also differences in how our immune systems respond to vaccines. Now, in case you don't remember what vaccines are, here's a recap. Vaccines are made in order to prepare our immune system to fight off a specific virus or bacteria. So how do these work? Well, here is a random virus. It is not really blue, it's just been colored for clarity. And every virus has these things sticking out of them called antigens. In order to prepare our immune system to fight off this virus, scientists actually remove the antigens and put them in the vaccine. And this vaccine is injected into us. Now, these antigens enter our bloodstream. However, they are perceived as foreign invaders, so the immune system fights the infection. However, this is a fake infection because the whole virus is not present. Still, the immune system fights this fake infection, so if or when the real virus comes, the immune system will be fully prepared to fight off the real infection. Unfortunately, even when a group of people are given the same exact vaccine, their immune systems can respond differently. Let me show you a study that illustrates this. A group of children were given the MMR vaccine, also known as the measles, mumps, and rubella vaccine. Their first dose was given at 15 months of age, and their second while they were in kindergarten. Several months later, their blood was drawn to measure each child's strength and immune response. Here's what they found. 56% had a strong immune response to the MMR vaccine, meaning they would be fully prepared to fight off the virus if it infected them. 38% had a medium immune response to the vaccine, meaning they would be less prepared to fight off the infection. And surprisingly, 6% had a weak or no immune response to the same exact vaccine given to all the children. It is like they did not get the vaccine at all. And because of these differences, we can say that there is heterogeneity of immune response to vaccines. So what causes this heterogeneity? Well, one well-known factor is age. As infants, our immune system is relatively weak, but as we grow, it matures, and at adulthood, the strength of the immune system plateaus, and later in life, the strength starts to decline. However, a less well-known factor that also influences our immune system is mood. Let me tell you a study about this. A group of elderly patients were asked to record daily their physical activity, nutrition, sleep, stress, and mood. And again, this was daily, and they did this for 2 weeks before the flu shot and 6 weeks after. A blood sample was drawn at the end to measure each participant's strength and immune response. And out of all of these factors, they found that mood was the only factor that correlated with a stronger immune response. Specifically, a better mood on the day of the vaccination correlated with a stronger immune response, leading to a lower risk for influenza. Now, I found these results intriguing, and I wanted to replicate them here at Shattuck. However, I knew the ethics review board would not be happy with me drawing blood, so I designed a much simpler study. And this led to my project, The Effect of Mood on the Immune Response to the Influenza Vaccine. And based on all the information I've told you, I have hypothesized that a better mood on the day of the vaccination will correlate with a lower risk for influenza. I started my project by gathering 123 SSM students and faculty. I asked each participant to fill out a mood survey on the day of the vaccination. This mood survey is the same one they used in the previous study with the elderly participants. And here I am administering the mood survey at the porch at Kramer House. And after each participant filled out their mood survey, they immediately got their flu shot. And then I waited 4 months for the flu season to occur, and then I determined if they had the flu. Now, how was I, Hannah Rahn, a high school student, supposed to be able to know if my participants got the flu? Well, I used a questionnaire modeled by the Minnesota Department of Health and University of California, Davis to answer this question. I started by asking each participant if they got lab-confirmed influenza over this past winter. If they said yes, obviously they had the flu. But if they said no, I asked additional questions of, did you have a fever, chills, sore throat, or cough? If they said yes to these, then it was likely they had influenza. But if they said no to any of these, it was unlikely they had influenza. So what did I find? Well, here's the average mood score for 2 groups. The first group is the group that did not get the flu. Their average mood score was 15.59. And the average mood score for the group that did get the flu was 8.65. Now you can definitely see that there's a difference between these mood scores. The no flu group is higher than the flu group. But was this difference due to chance? Well, to calculate this, I need to find a p-value. This tells me the probability that the difference in my data was due to random chance. In order for p-value for data to be statistically significant, the p-value has to be less than 0.05. My p-value was 0.003, meaning there was a very low probability that the difference in my data was due to chance. So therefore, I can conclude that my data is statistically significant and it supported my hypothesis. Yay! And my hypothesis was a better mood on the day of the vaccination correlated with a lower risk for influenza. So, what can I do with these results? Well, healthcare providers could try to improve the patient's mood on the day of the vaccination. And for example, here at the Kramer House, we could give out the cookies before the flu shot instead of after. However, with all studies, there are flaws. One could be, or is, participants with a better mood might have stayed healthy even without the flu shot. And therefore, I need to do a better controlled study. And another flaw is I need many more people to confirm my results. And even though I found a correlation between mood and vaccine effectiveness, fortunately, correlation does not equal causation. And therefore, a future study in this line of research would include exactly figuring out how mood affects immune response to vaccines. Thank you so much for listening and everyone who participated in my project and helping.